basic trigonometric equations. You've already been doing them, okay? Basic trigonometric equations. Oh, thank you. All right, so let me, what's a coterminal angle? What's coterminal mean? What'd you say? Shares the same position. That's good right there. Okay, so let's say this. What is, if I said in terms, well, let's just do it in degrees first. 60-degree angle. Give me one coterminal angle to it. Let's see if you really get it. Same position. What? Negative 300. So if you go this way, that's negative 300 degrees, right? Give me a positive one. So we go up to 60. That's a degree that we have. All of these two are the same. Give me a positive one that's the same.
440.
How did you get it?
Add 260.
Yep. Going up to 60 and then added 360. So you added 360 to that. You got 420. So those are all three the same. So coterminal angles. Okay? What if I said in terms of pi? What is 60 degrees in terms of pi? Pi over 3. Okay, and then I would say, okay, give me a negative and a positive in terms of pi. What would you do? Excellent. That's what I want to hear. You'd add 2 pi and you would subtract 2 pi. Okay, so do that and come up with your answer. It doesn't get much harder than this. Okay. It does get a little harder, but not much harder. So you gotta get a common denominator. What do you get from that one? This is 6 pi, right?
Yeah.
Plus 1, 7 pi over 3. Okay? And again, common denominator. What's 1 minus 6? Okay. Negative 5 pi over 3. Hard to tell. Alright, so here are 3 answers in terms of pi. Here are 3 answers in terms of degrees. Okay? Today you're going to be really giving me your answer in terms of pi. And this is kind of how we're going to do it. Or it is how we're going to do it. Okay, so let me push you a little bit further. Let's just do something very simple. Something that you know. Alright? Start with a lot of the problems today you're going to know what the answer is, okay? So I want to know at this point what, in terms of pi, what value is this when y is radical 3 over 2? First of all, what is the degree? Start with that. Radical 3 over 2. 60 degrees, what is that in terms of pi? 5, what did you say? Oh, on the board, I thought you said 4. Pi over 3. Alright, so this is pi over 3. Okay? And then it's going to ask you this in future references. This is how you should think about this. It's not just for today, but this is how you should think about this answer. There are infinitely many answers to this problem because you can go around the circle how many times? How many times can we go around the circle here? As many times as you want. Well, how would we say that? Well, the first thing you did is you said you would add pi. That's great. How many times can you do that? As many times as you want. Well, how do we say that? We say that with a letter. Well, let's say it's K. K represents how many times you're going around the circle. And that's what they say in the book. So when you're looking at your answer key and you're seeing things like plus 2k pi or minus 2k pi, you can subtract. Okay? And you should do that. You should go the other direction as well to get some of your answers. But this is what it's looking for. Give me all the solutions that make this true. And you'd say this. Except this isn't everything. Because y is not just square root of 3 over 2 at pi over 3. That's the square root of 3 over 2. Right? That's your y value. But it's also the square root of 3 over 2 right there. What is that value in terms of pi?
2 pi over 3.
2 pi over 3. Now, am I going to go down here? Why?
Negative.
Yeah, because they're negative. Because I'm asking for the sign of a positive value. So, this is half the answer. The other half of the answer would be this one, 2k pi. 2 pi over 3 plus 2k pi. Or minus 2k pi. So if I go around the circle once, then that means k is 1, and I'm just adding 2 pi to each of these. If I go around the circle twice, that means I said k is 2. That would be 4 pi plus 2 pi over 3. And you give me the answers. So it's going to ask you for like 6 solutions. So you're going to have the original 2 or 1, whatever the parameters are that they give you. And then I need 3 more of these and 3 more of those. Okay, we'll do one here in a minute. Okay, so let's talk about cosine. We're just going to do some examples here. Cosine of theta is -1. Alright, so in terms of pi, where is x -1, Hannah? Where's x -1 in terms of pi? Pi. Good job, Hannah. Yes, pi. So, all the way around your unit circle, here's pi. Remember, that's -1, 0. So, our answer here would be pi. There isn't 2 answers as far as like what we have here. Alright? The x value is -1 only in that position. So, you would say plus 2k pi. And if I said I want 5 more solutions, what would you do? You could do the backwards part. You could get that one out of the way and say -5. Okay? And then you could keep going around in the circle. So if we go around the circle once, k is 1, that's 2 pi. What's 2 pi plus pi? 3 pi. Alright, we got 3 answers so far. 1, 2, 3. Okay? And if k is 2, that's 4 pi plus pi. What is that? 5 pi. Alright, we got 4 answers. 2 more. Give me 2 more answers. See the pattern yet? What'd you say? 7 pi. And 9 pi. You didn't have to go negative. You could say 11 pi if you wanted to get to 6 answers. So there you have 6 answers. If it asks for 6 solutions, and it will on some of the problems, that's what you have to do to get to it. How's that? Not too bad? That was number 7. We gotta get to number 40. Okay. We're not gonna do 45. I'm just saying we're gonna get to some more difficult problems. Alright, so this is just understanding what you already know, but we're saying give me the coterminal angles to those answers. Alright, so let's change this just a little bit. What happens when you don't recognize these? So remember, put your calculators in radian mode. And you look at that and you say, well, wait a second, I don't know where that's at on the unit circle. Okay? So this is what we're talking about. Here's your unit circle. And where is y -0.3? Okay, on a unit circle, it's a unit circle because this is 1, right? Alright, well, if y is negative 0.3 and this is negative 1, negative 0.3 is about right here. And so on the unit circle, we're at that position, and we're also at that position. This is radian measured. That's the distance when y is negative 0.3. This is the y value. I want the radian measure, which is this distance. They're going to be pretty close, aren't they? So anybody figured it out yet? How do I figure it out? I take the arc sine of negative 0.3. And you should get something very close to negative 0.3. What do you get on your calculator? In radian measure. Make sure you're in radian mode. Who's got the calculators? There's not a lot of calculator problems on here, but I want you to understand what it is you're finding. When you have a problem you don't have the answer to. What do you get? Radian measure. Who's got the calculator?
Negative 3.047.
Negative 0.3?
Yes, yeah.
Negative 0.304?
Yeah.
Okay, whatever. Very, very close because this distance, the y value is a vertical line here, vertical distance, and the circle is just curved. So they're very, very close to the same until you get, down here somewhere. Then your distances change a little bit. So as the closer you get to the x-axis, these are very, very similar. These two numbers. So here's the point. What are these points? Well, if I go from here all the way around to this point, how far have I gone? So far, where am I at? What's this distance? Pi. And what is pi as a number? 3.14. What's this distance right here?
3.17.
No, just this from the x-axis to here. Yeah, it's 0.3. The distance is not negative. I was just asking what this is. It's 0.304. Okay, well, what's 3.14 plus 0.3? So we just rounded the 0.304 to just 0.3. And then you get your position from all the way here, all the way around to there. 3.44. Alright, so that's one of those positions. Plus 2k pi. Once you start thinking like that. Putting the 2k pi on it because it's going to say how many times you're going around. We'll address this here in a second. How do I get to here? Well, if I'm talking positive, I gotta go all the way around. All the way around is how far? 2 pi, which is what as a number?
6.28.
Everybody follow? 6.28. 2 times 3.14, 6.28. So 6.28, well, don't I need to subtract this amount to get to this? So subtract 0.3. You get 5.98 plus 2k pi. So this is just an example showing you how to come up with measures based on radians. It's still in terms of pi. We put pi in here, but it's as a number. So if I wanted another number, I would say if I went around again, I would have to add if I did one time, 2 times pi is 6.28. 6.28 plus this, that would give me my next number, coterminal position. Yes? Everybody got that? Pi is 3.14. Okay. Knowing those positions. All right. So let's do this one. That's number 18. Now we're getting up there. Cosine of theta equals 1/2. In terms of pi, when is x 1/2? In terms of pi, on a unit circle. Where's x 1/2?
60
60 degrees. Just happens we use the same one for this one. It's no big deal. 1/2. But it's also 1/2 right here, isn't it? Okay, so first of all, what are those in terms of pi? What's this one? 5/3, thank you. Okay. What's this one? Yes. 5/3. Was that hard? Every you circle out in front of you, it's a struggle. If it's a number like that over there, then you need to use your radian measures and 3.14 for pi instead of just the symbol. Okay. All right. Let's do this one. It's number 40. Tangent of theta minus 2 times the quantity of 16 sine squared of theta minus 1 equals 0.
You said it wasn't going to be hard.
What did you tell me the answer was if I gave you this in chapter 1? What's my answer? How did you solve that? I solved it. Here, I'll write this down for you. Everybody knows how to do this. Nothing new up here. Get rid of the square. Take the square root. Sine of theta is now plus or minus 1/4. Again, you don't know the tangent of theta equals 2, so you have to do the same thing we did over here with the radian measures.
So the sine.
You don't know 0.25 either. Okay, so you're gonna have to use radian measure for that. Excuse me.
But for those, like the sine is no different than like x or whatever.
Well, this is your y value. Where is the y? 1/4. Tangent theta is 2/1, y over x. Okay. But the whole point is that you have to use the arc tangent and the arc sine to get those values. Alright, so the arc tangent of 2 is what on your calculator? Got a calculator, what's the arc tangent of 2? 1.1, okay, so 1.11. Good enough. Plus k pi. Tell me why it's not 2k pi. So look at their notes back in inverses. Or on your reference sheet for the domain and range of tangent of inverses, arc tangent. We got the reference sheet out with that on it. It was one of the beginning things we put on there in chapter 6, I think. Nobody has it? Because the tangent has an interval of pi. Tangent and sine go from where to where on the unit circle?
Negative pi over 2, pi over 2.
Yeah. Has an interval of pi and goes from negative pi over 2 to pi over 2. So you have to have these out. Those out just to make sure you are answering the correct portion of what you have over here. So what's 3.14 pi over 2? 3.14 divided by 2 on your calculator. 3.14 divided by 2. What is it? 1.57. Just to give you an understanding of where we are. So 1.11 is about somewhere in here. So that's where we're talking about. So this part is within the parameters of arctangent. So if I add 3.14 to it, I'll get 4.25. If I add 6.28 to it, 7.39. But where is that at? It's got to be in this section. So when you're looking at this, be aware of what sine and tangent needs, arctangent and arcsine are in. That's the only thing. Everything else is the same type of thing. Knowing where it's at, getting coterminal angles, but the arctangent's a little bit different in the arcsine. So you got to know those and be able to come up with that information. Okay. The sine. What'd you get for the arcsine of 0.25? Raise your hand if you got your graphic calculators. Okay, then I want you to answer. Okay, what is the arcsine of 0.25? Yeah, it's very, very close. Remember, it's just like that 0.3. It's very close to the x-axis. The same thing for negative 0.25 is going to be negative 0.25 as well. Okay? So you have to add, what are we adding to it? 0.25 plus 2k pi. Why? Because sine goes all the way from, all the way around the circle. And again, these are both plus and minuses. So you're going to get lots of different answers here. Don't forget this. This is the only weird one. Okay? So you got to have that. All right, here's your assignment. Most of which, on the test, this is really what I'm looking for. Can you understand this stuff and give me multiple answers? That's really what I'm looking for. This is just to stretch you. One of your problems is a trinomial, just like we had in algebra, but it has trig functions in it, and you factor it into two binomials and work it down from here, just like this. So you're going to be given a trinomial, and you have to factor it. Page 522, 9, 17, 19, 25, 29, 33, and 41. All right, good.